Hi, welcome back for Chapter 2, Section 5, Water Power. Today we're going to learn about how can the energy of moving water be used to produce electricity, and what are some advantages and disadvantages of hydroelectric power plants. Okay, so let's get started. Okay. A raging river that overflows its banks can wash away homes and uproot trees. The river has power. Imagine if we could harness this power as an energy source. Guess what? We can. Since ancient times, people have used the energy of moving water to grind corn and transplant goods. Today, the energy is also used to produce electricity. One of the world's largest dams, the Itaipu, produces more energy than 13 nuclear power plants. Straddling the border between Brazil and Portugal, the dam took 18 years to build and contains enough iron and steel to make 380 Eiffel Towers. More than 75% of Paraguay's electric needs are supplied by the dam. Paraguay is just one of many countries that rely on the energy of moving water as a source of electrical power. Okay. Here's a picture of water wheels. A water wheel, the potential energy of water is changed to kinetic energy when it hits a water wheel. Okay, energy and moving water. Have you ever seen a fast-moving river propel a kayaker along? If so, you know how much energy moving water can have. It can move boats, carve out canyons, and sweep away cars in a flood. Okay, we've talked about, especially last year, you should have talked about kinetic and potential energy. Okay, the energy that sends the kayak through the rapids is kinetic energy. Kinetic energy is the form of energy that an object has when it's moving. So kinetic energy, it has to be moving to say it's kinetic energy. So moving water is kinetic energy. Energy can change from one form to another. If the water's movement is stopped, all of the energy becomes potential energy. Potential energy is energy that is stored and waiting to be used. Okay, so if it's still water, it has a potential to be moving, but it's still stopped. So if it's not moving, it is potential energy. So that's the difference between potential energy and kinetic energy. To understand how energy changes form, imagine that you are holding a baseball bat at the top of your swing. The ball at that point has potential energy. As you swing at a ball, that bat's energy becomes kinetic energy. If you hit the ball, the energy is transformed again, becoming the kinetic energy of the ball. Okay, so we have a bat up here. It's not moving, right? But it has the potential to move, so it's storing potential energy. As it moves, it changes into kinetic energy. Okay, if it hits the ball transforms energy, or the bat transforms its energy to the ball, producing kinetic energy. Okay, so water has the same thing. Still water is potential energy, moving water has kinetic energy. Energy from moving water. Electricity produced by the kinetic energy of water moving over a waterfall or through a dam is called hydroelectric power. Hydro means water, right? So power coming from water. So to generate hydroelectric power or hydropower, engineers built a dam across a river. Water backs up behind the dam, floods the valley, and creates a reservoir. The water stored behind the dam has potential energy. Okay, so it's stored, it's still, it has potential energy, which is changed to kinetic energy when it is released. So you pull up the dam, water moves, so now it's kinetic energy. Hydroelectric power plants capture the kinetic energy of moving water and changes it into electrical energy. Okay, what is potential energy? Energy that has the potential to move, but at that point it is just storing energy. Okay, so here's a hydroelectric power. Hydroelectric power is generated by changing energy from one form to another. So here we talk about the reservoir. Let's see if I can get some highlight here. So right here is the reservoir. The water stored behind the dam has potential energy due to gravity. When the water flows through the penstock, the kinetic energy of the moving water turns the turbine blades, producing a mechanical energy. So the water moves down here, okay? Okay? So as the water moves, this turbine is connected to a generator that contains an electromagnet. The turning shaft turns the magnet and produces electrical energy. So right here, now I'm looking at these little shafts right along here, right? Oops, right there. Okay, so right here, that's the shaft. It turns, okay? And as it turns this shaft right here, okay? And then this electromagnet in here is turned through this shaft. And as it does that, it stores the power that's producing over here in the generator, okay? So then that stored energy up here is transferred through cables to people's homes, okay? So hydroelectric power plants. Figure 25 shows a hydroelectric power plant. In this diagram, you can see how the kinetic energy of moving water is changed into the electrical energy that lights homes and runs computers. So we went from potential energy to kinetic energy. Okay, the water then changes its kinetic energy into electrical energy through this turbine and this generator, and that goes to our homes, okay? Advantages. In some ways, hydroelectric power seems like the ideal way to produce electricity. Hydroelectric power is clean, safe, and efficient. Building a dam is expensive, but the water is free and is naturally renewed by the water cycle. Unlike power plants that burn coal or oil, hydroelectric plants do not contribute to air pollution. In the United States, hydroelectric power accounts for about 9% of the electricity produced, while worldwide it generates about 20%. Some countries such as Norway and Brazil produce almost all of their electrical energy through hydropower. Okay, so that's advantages, but there are some disadvantages. Okay, hydroelectric plants do have limitations, however. Only certain locations are suitable for building a dam. Okay, so in Kansas, there's no water, so you can't build a dam there. So you can't have hydropower plants, right? Okay, a fast-moving river is necessary, as is an area that can be flooded to create a reservoir. Okay, so you have to be able to create a reservoir. So you have to have enough water, right? Dams also affect all living things in the area around them. What was once a fast-moving river becomes the still deep waters of a What was once a fast-moving river becomes the still deep waters of a reservoir. Some organisms cannot survive the change. Flooding the land behind a dam can destroy wildlife habitats, as well as farms and towns. In addition, the dam forms a barrier across the river. It may prevent fish from traveling to the parts of the river where they usually lay their eggs and hatch their young. In some places, people have suggested building small dams to supply power to a local area. Smaller dams uproot fewer people and do less harm to the environment, while still providing energy for the region. However, since dams are expensive to build, small dams may not produce enough energy to be worthwhile. Large dams, on the other hand, produce great amounts of power, but they also have a major effect on the land around them. Okay, so the Three Gorges Dam in China has displaced more than 500,000 people. Eventually, it may displace more than 1 million. Also, historical artifacts such as the ones shown here have had to be relocated. So you can see there are advantages and disadvantages of hydroelectric power. All right, that is the end of our lesson today. Do Section 5 assessment, and you also need to start working on the study guide. Okay, I will see you next time. Have a good evening. Bye.